Welcome to the toolroom of Insight, a graph-augmented RAG-based tool that helps developers automatically localize bugs and get repair guidance within their repositories. Debugging large repositories is a slow and tiring process. Developers manually search through many files and rely on keyword search that often misses the right code. This makes issue triage and bug localization error-prone and costly. Traditional IR and ML-based bug localization rely heavily on textual overlap and handcrafted features, and often stop at ranked list of files. New deep models improve semantics but rarely combine rich repository structure with LLM reasoning. Insight aims to bridge that gap. Insight reads an issue, understands it in natural language, and semantically searches the repository to find likely buggy files and code entities. It then uses an LLM to express why the locations are suspicious and what kind of change might fix them. Insight listens to GitHub webhooks, indexes the code with tree and stores embeddings in a FAISS vector store. It also builds a Neo4j graph of callers and callees and dependencies, and uses an LLM plus a workflow manager to coordinate retrieval, graph enrichment, and response generation. When a new issue arrives, Insight generates a semantic query, retrieves top key candidate entities, enriches them with graph context, and the LLM has to select the most suspicious location. The system then returns the ranked files and functions with brief explanation and patch hints back to the issue. Insight currently supports Python and Java and can be extended easily to other tree languages. It can be installed as a GitHub application. In summary, Insight combines semantic retrieval, code graphs, and LLM reasoning to deliver repository-aware bug localization and repair guidance. As a tool, the goal is to cut down debugging time and help developers focus on fixing, not just searching. So let's move on to the simple demonstration process of Insight. First, I open the Insight website and click on the installation button. This redirects me to the GitHub application page. I click install here and the app is added to my GitHub account. So as we can see that the app is already added to my GitHub account. Now I open the app configuration and choose which repositories I need to give access, and then I add them to the installation list. So we select a repository from our existing So as we can see that a repository is added, compliance checker. Now if we go to the repository, we can see the repository is here. And now we will create a new issue on the repository. So if we click on the create button to create a repository, create an issue, then the Insight will now process the issue with the issue description and provide us a comment to hang on a little bit. So here are the localization results. As we can see, the Insight found 3 methods that are likely to be buggy for this issue. And if we click on the methods, we can go directly in the file on the specified method where we are looking. Then we have a technical analysis, and then in the last part we have how developers generally address those issues. So to conclude, Insight fits naturally into the GitHub workflow. You install the app once, connect to the repositories, and then simply keep the issues as usual. Behind the scenes, Insight indexes your code, leverages semantic retrieval and graph context, and uses LLM reasoning to point you the most relevant places in the code base.